So in section 3, the last subject is using the Descartes rule of signs. So Descartes rule of signs basically is what we can do to determine how many positive, negatives, or imaginary solutions we can have. It's just the number of solutions that we can have. So it's not actually gives us any solutions or the possibilities, what the possible solutions are. It just gives us how many of those solutions are there. How many positives there might be, how many negatives there might be, or how many imaginaries there might be. So what you have to do is you have your polynomial, and you're just going to run through the sign changes. Okay, so we're just looking at pretty much the sign of the coefficients, okay, when they're in order, so they have to be in standard form, which this one is. So that's fine. And we're just going to count the number of sign changes, okay? So it goes from positive to negative, so that is a sign change. So yes, that's a sign change. From negative to positive, that is a sign change. And from positive to positive, that is not a sign change. Okay, so that's not a sign change. So we have two sign changes. And so what that tells us is the positive answers that we're going to have, are positive zeros or positive solutions, will be 2. So the positive number, or the number zeros that will be positive is 2. So we'll have 2 positives. That's a terrible way to write it probably. So what I do is I just make a chart. So you have positives, you have your negatives, and then you have your imaginary, and then you have your total. Okay, so we look at the degree. The degree always gives us our total, right? That's what we learned from before about the fundamental theorem of algebra with the conjugate zeros and sorry, I'm not thinking of the other one, but the other one's another the number of zeros theorem, right? So this one gives us 2 positives, and then it decreases in order by 2's. Okay, so I have the possibility of 2 positives, or I have the possibility of 0 positives. Okay, so it decreases by 2. So you have to count for that. That means, and I need a total of 3. And remember, conjugates, from the conjugates theorem, that they also come in pairs, right? So I can't have 2 here. I can have 2, 4, they can only come in pairs, right? But if I had 2 here of imaginary, that would be bigger than my total of 3. So the other one has to be negative, right? Okay, then, so that's how you find the number of zeros that are positive. To find the number of zeros that are negative, what we have to do is we have to take a -1 and plug it in for x, and then that will change the sign here. So if I plug in a negative in for x and I cube it, I will still get a negative. So my coefficient in front will be negative. If I plug a negative in the second term, the negative squared is a positive, and a positive times the coefficient is negative. So the coefficient of the second one will be negative. If I plug a negative into the x here and times it by 2, that coefficient will then turn negative. And then I can't plug it in because there's no x to plug it in on the +7, so that constant will remain positive. Now I count the number of sign changes. So no sign change there, no sign change there, and there's 1 sign change there. So that's why there's a total of 1 sign change here. So there's total of 1 sign change so there's total of 1 sign change. So that means that I have 1 possible negative. And now, since I look at after I drop down by 2 on my positives, I can't drop down by 2 on my negatives because I only have 1. But those would also drop down by 2. But since they can't drop down by 2, I have to do my second row here. So I could still have the possibility of having 1 negative, but with 0 positives, and that means my imaginary, I would have to have 2 imaginary to get to my total of 3. So that's how you do it. And let's do another one because that's probably sounds a little confusing. Let's go back. So let's take on another one. Okay, so what you do, I just make my chart. I look at my degree, right? And that's going to be my total number. So my total largest degree is the largest exponent, right, which is 5. So I need a total of 5. Then I want to figure out my positives. And I figure out the positives by just counting, looking at the coefficients, and looking at the sign change. How many sign changes are there? So I go from positive to negative. That's a sign change. So you can count. You could literally count if you want to instead of saying yes or no. 1. There's a sign change there, so that's another sign change. There's a sign change here, so there's 3 sign changes. This doesn't change, or this does, sorry. There's another one, so 4. And then it goes positive to positive, so there is no sign change there. So there's a total of 4. So there's a total of 4 positives. So I could have 4 positive solutions. But then I need a decrease in order, right, by 2. So I could have 2 positives. Decrease in order again, I get to 0. Okay, so that means I'm going to have 3 different ones. Now I need to figure out my negatives. So I plug in, to find out my negatives, I plug in a negative in for all my x's, and then use my exponents to figure out what the sign of the coefficient will turn to. So when I plug a negative in for this x and multiply it by itself 5 times, I still get a negative, and a negative times 2 would be a negative. So that coefficient would be negative. When I plug a negative into x to the 4th, it will turn positive. And then that positive times this negative, the coefficient is negative. So the second term also has a negative coefficient. And to the 3rd, a negative cubed will be negative, and a negative times this positive is negative. So the 3rd coefficient will be negative. A negative squared is a positive, and a positive times this negative right here out front is going to turn negative. So again, there's no sign change there. And then a negative here, a negative times a positive will be a negative, and then we have our plus 5. Okay? So, I didn't have to write plus 5, but it's a positive. So then I count the number of sign changes. No sign change, no sign change, no sign change, no sign change, 1 sign change. So there's 1 sign change, so that means I have 1 negative. Okay? So I can have 1 negative here. It can't decrease in order, so it just stays 1. And 1. Okay, now I have to come up with my total of 5, and that's where the imaginary falls in. And remember, the imaginary always comes in groups of 2. So 4 and 1, that equals 5. So there's going to be no imaginary for this situation. So I could have all 4 positive and 1 negative. I'm not going to have any imaginary. Or I could have another scenario where if 2 of them are positive, I would have 1 imaginary. So that gets me to a total of 3. So that means I need 2 imaginary to get to my total of 5. And then I could have 0 positive, 1 negative, and then I would have to have 4 imaginary solutions to get to my total of 5. So you could have 3 different scenarios. Okay? What this at least lets you know that at least one of them is going to be negative, right? What kind of stinks is the positive, since I have 4, it decreases, right? So I still have 3 different kind of situations that I could have, but at least I know that one of them is going to be negative. One of those possibilities that you do your P over Q is going to be negative. All right, let's look at another problem. Okay, so here's another problem. It's not necessarily asking us to use Descartes' rule of signs and find what are the possible, or the question would normally ask to use Descartes' rule of signs and to find the different possibilities of the numbers of positive, negative, and non-real complex zeros. But this asks to find all complex zeros, so it's asking us to find all the zeros, both imaginary and real ones. Well, even though it's not telling us to use Descartes' rule of signs, we actually can. So we count the number of sign changes. There's no there because positive, 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 negative. There's 1 there. And then from negative to positive, there's another 1. And from positive to negative, there's a 3rd one. Okay, so there we have 3 sign changes. So since we have 3 sign changes, we can make our list. So positives, negatives, imaginary, and our total. And since our degree is 4, that means I need to get it to a total of 4. So I have 3. Well, I know right off the bat that it has to be 1. There has to be a 1 here, right? Because I need a total of 3, and the imaginary have to come in pairs. So it goes 3, 1, 3 positives, and 1 negative. And then the positives are, your numbers always decrease by 2. So if my positive's 3, I could have another scenario where I have a possibility of having 2 positives. and I can still have my 1 negative. So actually that would be a total of 3, but I can only have 1 negative. As you can see, if we run our negative through, so a negative to the 4th is a negative to the 3rd is a negative squared is a positive, and positive times negative 9 there would be a negative coefficient, and negative times 11 would be a negative, and we have our negative 4. So here I didn't, this one's actually positive, right? Because x to the 4th times a negative to the 4th would be a positive, so that is a positive. So there's one sign change, and none of these are sign changes, right? So we have one sign change, that's why we had this 1 here, so we have 1 here. I didn't decrease my positives by 2. You always got to decrease by 2. So the negatives, we do have 1, right? We do have 1. Come on, Ben. We do have 1, so it can't decrease by 2. So I just leave it as 1. And we saw that by plugging in our negative and seeing that we get 1 sign change. But we can decrease our positives by 2 because we have 3. So if we decrease that by 2, we get 1. And then 1 and 1 is 2, so we need 2 imaginary to get that total of 4. And that's all I can do because I can't decrease by 2 anymore. So those are the only possibilities we have. So we either have 3 positive and 1 negative and no imaginary, or we have 1 positive, 1 negative, and 2 imaginary. So what this kind of helps is, as we're finding all the zeros, how this helps us is because now when I, undo that, I erased. So how that helps us is when we list our p's and q's, our p's over q's, factors of -4, which is positive and -1, positive and -2, and positive and -4, divided by our factors of our lead coefficient, which is 1, so they're going to be the same. So that lets me know once I find one of them, if it's negative or if it's positive, then that lets me know that I might have 2 more positives. But if I find 2 positive solutions, that means it's going to be this case, right? So then I would know that there's another positive out there to find. Okay, so if we do that, we can go ahead and run synthetic division. Make sure nothing's missing. 4, 3, 2, 1, and 0. Okay, we're good. Okay, so plug 0 in that row. We can start trying them. We need to get a positive 4 here to get 0. So always try 1. 1, 2, 2, -7 is -7. That's a 4, and that is 4, 0. So that means x equals 1 is a solution because I got a 0 as a remainder. So these both possibilities are still open, right? Because I have just one positive. So then I can use those as my coefficients, and I can do maybe try -1. So 1, I need a -4 here, right? So that's -1, 1, and a -1, that's a -8, so that's not going to work. So maybe +2. So if I get another positive, that means I'm going for this scenario, so that means I know there's a third positive out there. So if we try 2, run it through, 2, 4, 8, 1, 2, so no, that's not going to work. So we could try -2, -2. So -2, -2, that's 0, that's 0, that's -7, that's not going to work. How about 4? So 1, 4, 6, 24. 24 is way too big. -4, that'd be -4. That'd be -2. That'd be a +8. That's 1. And that'd be a -4. So there's our negative, right? So we know now, because I already tested +4, that this is the case right here. So this is our case. We have our positive, we have our negative, and now the last 2 are going to be imaginary. So, and now this drops down to a quadratic, right? So we know they're going to be imaginary. So we have x squared minus 2x plus 1. which we can see this is not factorable. Wait. Make sure I have it right. Actually, it is factorable, right? Because the factors of 1, what times what is 1 but but adds to -2? That'd be a -1 and -1. So we have a multiplicity, right? So x equals 1. So we have one answer there, and then also this one, and the one up here. So really got caught off guard because we have a multiplicity. So it was actually 3 positive answers. So 3 positive answers. I'm not going to do that one. 3 positive answers. X equals 1, multiplicity of 3, and then x equals -4. So that's why I think I said in class, right? Even when you find an answer, so I found an answer 1. I think in class I told you, go ahead and make sure if you can't find any more to always plug the answer that you found the first time back in to see if it's a multiplicity. It did work out for us. There are all 3 positive answers and 1 negative answer, so we don't have any imaginary. Okay, so your homework would be page 316, number 75. So I'll do this one. Okay, so here it is, and we're finding what are the possible number of positive answers, negative answers, or imaginary solutions. Okay, so that's all this asks you to do. So you don't actually have to find what are the actual zeros, just the possibilities. Okay, so we have positives, we have negatives, we have imaginary, and then we have our total, right? So our total is our degree, which is 3. So then we run through our sign change. There's a sign change there, yes. There's a sign change here, yes. And there is no sign change here, right? So there's 2 possible positives, and then they decrease in order by 2, right? So 2, or sorry, 0. 2 subtract 2 would be 0, or would be 0. Okay, so that means that we have 2 possible positives. So the top scenario here, it has to be a total of 3, and imaginary can't come in. They have to come in pairs. So that means our negatives would be 1. Right, and we can see that when we plug in a negative cubed is a negative times 2 would still be a negative, and then a negative squared would be positive, and positive times -4 is a negative, negative times positive 2 is a negative, and then we have +7. So we see that we only have 1 sign change here, right? There's only 1 there, so that's why we have 1 right here. Okay, so then if I have 0 positives, I still have my 1 negative because I can't decrease in order, right? If I had 3 sign changes on the negative, then I would have 3, 1, and so on. But there's only 1 sign change. So that means I have to get my total of 3, I have to have the 2 complex solutions.